In this lesson, we look at the methodology for carrying out the first step of autonomous maintenance. This step aims to remove all foreign substances such as dust, particles, grease, sediments and debris that may adhere to machines, tools and jigs. It is not simply a conventional cleaning, but rather a thorough cleaning that leaves the equipment completely free of any contamination. At the same time, an inspection of the machine is carried out to detect possible anomalies and hidden defects that may exist in the equipment. The fundamental conditions for the proper functioning of equipment, according to the TPM approach, encompass cleanliness, lubrication, and proper adjustment of screws and bolts. These basic aspects must be systematically and consistently addressed to improve both equipment performance and workshop work systems. Cleanliness is crucial for removing any type of foreign particles that could cause abrasion, wear, vibrations, loss of precision, and other problems that could lead to equipment failure and downtime. From the perspective of autonomous maintenance, cleanliness aims to reveal potential hidden defects, to correct them and eliminate them promptly. Lubrication stands as one of the most important requirements for preventing deterioration and maintaining equipment reliability. Since problems stemming from inadequate lubrication do not immediately manifest, this aspect is often neglected or given little attention to detail. As equipment becomes more automated, the number of points requiring lubrication increases, which may exceed the capacity of maintenance technicians to cover all these tasks. Therefore, the focus of autonomous maintenance is to instruct operators on the importance of lubrication and empower them to carry out lubrication routines as an integral part of their daily responsibilities. Almost all parts of the equipment are joined by screws and bolts. If these elements are loose or deteriorated, they can cause vibrations, leaks, contamination, misalignments, and malfunctions. Additionally, misalignments can occur due to expansions and contractions caused by temperature changes, which could result in serious failures. Establishing routines for regular adjustments is an essential task in autonomous maintenance. The first step of autonomous maintenance aims to identify and eliminate anomalies and hidden defects in the equipment through inspection during cleaning. By removing dirt, operators have the opportunity to carefully examine the equipment parts, enabling them to detect issues ranging from minor irregularities to serious failures that could compromise equipment reliability. These problems often remain hidden, not only due to dirt but also because of their limited accessibility for operators and maintenance technicians. The primary task of this step is to identify and rectify most of these anomalies to fully restore the basic conditions of the equipment. However, it may not be possible to eliminate all of them, as some may require specialized analysis for equipment redesign or investments to implement necessary modifications. The goal of this step should be to detect 100% of the anomalies and resolve more than 75% of them. In addition to eliminating hidden anomalies and defects, from a personnel perspective, this step aims to enhance operators' knowledge of equipment, systems, and components, as well as improve their observational skills through regular practices of thorough equipment inspection. The workers, who initially showed little concern about the cleanliness of the facilities, are gradually developing an interest in this aspect. This is because, as they interact more with the equipment and receive explanations about its operation, they understand the importance of carrying out this task. Findings are recorded on cards or lists that are then used to plan corrective actions. The change in attitude is achieved through small meetings and explanatory conversations that take place before and/or after cleaning and inspection tasks. These conversations are crucial as they address questions such as: what problems can the identified dirt cause? What are the sources of contamination? Is there a more efficient cleaning method? Are there loose, worn, or defective parts? How do these parts work? Would it be difficult to repair them if they break down? It is helpful to maintain a table or list where these questions are recorded and answers provided. During these conversations, workers suggest answers and propose corrective measures in team meetings. If they are unable to solve the problems, the supervisor may intervene or seek assistance from maintenance personnel. In this way, workers gradually increase their interest in understanding and maintaining their equipment, as well as learning to solve problems on their own or with the help of others. To facilitate the development of activities in the first step, we have structured 3 types of actions that must be carried out. 1. Initial inspection campaign and autonomous maintenance shutdowns. Several cleaning days will be planned to carry out the inspection of the pilot area or the entire production line. These periodic cleaning and inspection routines, called autonomous maintenance shutdowns, allow for maintaining the level of cleanliness achieved in the initial campaign and continue identifying remaining defects. 2. Development of technical and human skills for operators. In parallel with the inspection and elimination of anomalies, training activities will be carried out to improve the technical and personal skills of the operators. These training sessions will include development of technical competencies to enhance knowledge and practice in equipment care. Establishment of long-term habits, such as the systematic use of work standards, compliance with safety and hygiene standards, and proper information recording, among others. Strengthening working teams, defining roles and responsibilities, establishing agreements, and providing effective feedback. 3. Progress assessment and audit training. Actions will be taken to assess progress in the activities of the first step. This will include training operators on how to conduct an audit of the step, and how to identify areas for improvement to achieve certification of the first step. Occasional cleaning does not constitute an effective solution to optimize facility performance, as it does not adequately address the issue of equipment contamination. Conversely, regular cleaning, conducted with a systematic inspection approach, as proposed in the first step of autonomous maintenance, allows for the systematic identification of contamination causes and the development of solutions to definitively eliminate contamination sources. Below are some recommended practices to guide inspection work during the cleaning process. Incorporate it as a standardized activity in the daily work routine. Include cleaning of auxiliary equipment, peripheral areas, tools, and accessories used in the area. Completely remove dust, dirt, grease, oil, and other contaminants that accumulate in all corners of the equipment. Recommend measuring the time it takes for recontamination to occur, identifying its origin and severity. This information allows for studying solutions to effectively eradicate contamination. Detect any type of machinery defect using all 5 senses. Give due importance to control instruments, sensors, and actuators. The inspection process of a piece of equipment, through cleaning, involves performing 2 groups of activities. 1. Touching and closely observing the equipment. 2. Cleaning and removing contamination. While touching and inspecting the equipment, it is possible to identify 2 types of problems. Defective or damaged parts and pieces can be identified, such as missing screws, cracks, or surfaces worn by friction, among others. Areas of difficult access can also be identified due to lack of maneuvering space, absence of suitable tools, presence of covers difficult to remove, or compact arrangement of numerous components. When dirt is removed, it is possible to identify contamination sources, and questions arise about whether what is observed is normal or abnormal. This cleaning process not only helps maintain the equipment in optimal operating conditions, but also contributes to the early detection of potential issues and allows for proactive corrective measures to be taken. The identification and labeling of anomalies and defects represent fundamental steps in autonomous maintenance. This process involves visually highlighting the points on the equipment where a problem has been detected, either using colored cards or stickers, similar to the use of cards by a referee in soccer to signal player fouls. Originating in the Japanese industry, the card labeling method aims to collect valuable information about detected anomalies, which is then used in management to eliminate defects in the equipment. Operators must be trained in this labeling process to ensure uniformity in the criteria for identification, recording, and handling of the cards. Labeling is a procedure that not only facilitates the identification and rapid resolution of problems, but also promotes a culture of continuous improvement in the work environment. The standardization of labeling criteria facilitates communication among team members and encourages their participation in the detection and resolution of anomalies. In addition, the recording and tracking of tag cards provides valuable data that can be analyzed to identify trends, areas for improvement, and opportunities for optimization of the maintenance process. The initial inspection and cleaning session is an activity that generates high expectations for operators, supervisors, and managers. Executives also expect to see that the planned programs are functioning properly, and that the results will be highly beneficial. Operators and technicians expect to be able to identify problems that affect their work. In order for things to go as smoothly as possible, the following points need to be taken into account. 1. The upper management of the factory should consider the opening of the session as a significant event. They should provide some remarks on the importance of this session, express gratitude for the work done on that day, and encourage the continuation of such sessions to identify the maximum number of issues and defects in the work area. It's crucial to remember that the management supports such actions. 2. Safety measures must be taken and adhered to throughout the cleaning and inspection session. 3. Before the session, it's essential to ensure that all necessary elements are available. It's advisable to assign an operator to take care of this task. A list should be prepared of the items needed, not only for cleaning but also for essential tools, waste disposal, work documents, personal protective equipment, etc. 4. It is recommended that a maintenance technician guide the initial inspection steps, but it's essential for operators to actively participate in identifying anomalies and defects. 5. It's important to systematically organize the information collected during the inspection work, whether through cards, lists, photographs, videos, or audio recordings. 6. The allocated time for the session should be reported and monitored. 7. Upon completion, it's necessary to recall the practice of 5S to leave the work site organized and classify the waste for later removal. 8. Expressing gratitude for the work done and reporting on the achievements is essential. Additionally, a brief review of the activities required to eliminate the identified anomalies and defects should be conducted. It is recommended to evaluate the experience of the session to introduce new practices or improve existing ones. In the course introduction, we presented the CAPDO cycle as a fundamental element of TPM. This cycle features distinctive characteristics that make it highly effective for conducting continuous improvement processes in equipment, processes, and projects. By repeatedly applying the CAPDO cycle in the first step of autonomous maintenance, it's possible to gradually eliminate anomalies until achieving the goal of zero defects. Let's see how it works. During the check step, which takes place in the factory workshops, a thorough inspection and deep cleaning of the facilities are carried out to detect anomalies and process issues. In the action stage, corrective actions are formulated and implemented to address the identified problems and defects. The planning stage aims to prevent problem recurrence by establishing autonomous maintenance standards that are enhanced with each scheduled maintenance stop. Additionally, visual controls are established in this stage to facilitate early problem detection. Finally, in the execution stage, the established autonomous maintenance standards and programs are applied to prevent problems, and a re-evaluation is conducted to determine if previous efforts are sufficient or if a new cycle should be initiated. Implementing the CAPDO cycle in the development of the first step of autonomous maintenance involves scheduling multiple stops or inspections. Depending on equipment availability to accommodate production schedules, area managers can develop a stops plan within a time frame of 4 to 6 months. This plan enables negotiation with production planning and scheduling personnel regarding the timing of scheduled stops for autonomous maintenance. Several of these stops can likely be conducted concurrently with preventive maintenance activities. The concept of autonomous maintenance stop refers to a standardized equipment inspection task that is regularly carried out. In the manufacturing industry that utilizes autonomous maintenance, it is common to schedule interruptions of half an hour to 45 minutes every 2 weeks to perform cleaning, inspection, and adjustment tasks, especially in hard-to-reach areas or those requiring thorough cleaning and inspection. An autonomous maintenance stop can be structured into 3 important events. First event. introducing autonomous management practices in small work teams, and increasing specialized technical training. Some companies allocate no more than 10 or 15 minutes of stop time to perform activities related to work management, provide technical training, communicate relevant issues, and recognize team achievements and contributions. In organizations experienced in TPM, it is common to assign specific roles to operators based on the pillars of TPM. For example, one operator may be responsible for reporting on team training progress and lesson development from a point, while another may handle aspects related to safety and risk identification and elimination. Additionally, there may be an operator dedicated to reporting progress in anomaly elimination and OEE improvement, as well as a maintenance technician who reports on interventions made and pending tasks on the equipment. It can be concluded that the minutes before the autonomous maintenance stop can be used to promote autonomous management practices and improve efficiency and safety in the workplace. Second event, carrying out the cleaning and inspection campaign. The methodology has been explained previously. Third event, the closure of the cleaning session is also of great importance, as it is the moment when commitments are established to carry out actions derived from the inspections conducted. The committee responsible for the autonomous maintenance pillar can refine the stop standard with times and contents, using the experiences and lessons learned from each session. This standard helps increase discipline and the development of new work habits considered within the autonomous maintenance stop. In the practice of autonomous maintenance, we use a chart known as the confidence curve to record the number of identified and resolved anomalies. This curve, serving as a comparative tool, reflects the performance of the machinery inspection process. Generally, two types of charts are used. One to track anomalies managed by the maintenance department, and another for those handled by the operator team. The curve should demonstrate incremental progress, thereby showing that inspection and issue resolution are carried out in a disciplined manner. Conversely, a curve with peaks and valleys indicates a more random or impulsive approach to work. Ideally, this chart should be regularly updated by an operator assigned to this task as part of autonomous management. If the company has digital anomaly management systems, the operator will be asked to conduct periodic analyses, and their findings will be verbally shared with colleagues during team meetings. Here is the workflow for the inspection and elimination of anomalies carried out in the first step of autonomous maintenance. The process begins with a cleaning and equipment inspection session, using labels, checklists, or digital records to document observations. Subsequently, the area supervisor gathers the operators and develops a plan to address the detected anomalies. Before meeting with the operators, the supervisor meets with a maintenance representative to agree on which tasks the maintenance department should undertake and which tasks the production area should handle. In some cases, the team of operators must conduct diagnostic analysis using root cause techniques. Findings and action plans are documented in an improvement project document. The process continues with periodic meetings of no more than 15 minutes where operators, in front of the visual management board, evaluate progress with their leader and seek new solutions for outstanding anomalies. These meetings are crucial for motivating operators, as they provide a trusted space for them to contribute their improvement ideas. Achievements are recorded in graphs, management tables, or Kaizen reports, showing the comparison between the initial state and the improvements achieved. It is a good practice to include photographs illustrating the new conditions achieved. Finally, the management cycle includes an audit of the first step, where achievements are evaluated and the necessary conditions for certifying progress to a new step of autonomous maintenance are verified. If the required criteria are not met in the step audit, the cycle is repeated. The Step 1 audit is carried out to assess progress in both the identification process and the elimination of anomalies. However, in companies with extensive experience in TPM, it is common to introduce two additional types of audits, focusing on the development of human skills, leadership development, and visual management. Technical audits for cleanliness and equipment status are conducted by the operators themselves, who receive training on how to carry out this process. The main objective is to strengthen autonomous management to eliminate anomalies and keep the equipment in optimal condition. The supervisor also conducts an audit using the same format as the operators. These audits are carried out every 2 weeks, or when the supervisor considers the team ready to be evaluated by the Autonomous Maintenance Pillar Committee or the TPM coordinator to grant Step 1 certification. On the other hand, leadership and visual management audits are applied every 3 or 4 months by the TPM coordinator or a person designated by the Autonomous Maintenance Pillar Committee. The objective of these audits is to evaluate progress in the development of new human practices and work habits associated with autonomous maintenance. Operators do not participate in this kind of audit. These audits are designed to reinforce training in management skills and leadership competencies of supervisors and area managers. You can download an example of a complete Step 1 audit in the attached file.